So we know that the derivative of 5e to the power of 2x is just 10e to the power of 2x. Okay, and if we were asked to anti-differentiate 10e to the power of 2x with respect to the variable x, well, if we treat anti-differentiation as the reverse of differentiation, so we're seeing this relationship from one back to the other, we know that this answer would just be 5e to the power of 2x plus c. Okay, well, what is the relationship here? Well, when we look at the relationship in the derivative, what's happening to this 5 is it's being multiplied by the 2 in our exponent to give us this 10. So when we're asked to anti-differentiate 10e to the power of 2x, we have to think, well, when we differentiated something to give us this 10e to the power of 2x, where did that 10 come from? And that 10 has come about by a number being multiplied by our exponent 2. Okay, and if we think about a number which can be multiplied by 2 to give us 10, that answer is of course 5. So that's kind of the reverse of what's happening up here in our derivative. If we take a look at another example, so let's say that we're asked to anti-differentiate 6e to the power of 3x with respect to the variable x. Well, we have to think, if we were to have differentiated something and got to this point, so what is this the derivative of? Well, there's some number which has been multiplied by 3 to give us 6. And what would that number be? Well, it would be 2. So our answer in this case would be 2e to the power of 3x plus c. In fact, if we differentiated this guy to e to the power of 3x plus c, we see that we end up back with what is in our integral. Likewise, we could do another one. So the antiderivative of, let's say it is 15e to the power of 5x with respect to the variable x. What is this the derivative of is a good way to approach an integration or an anti-differentiation. What has happened to get us this 15? There's been a number that's been multiplied by our exponent 5. So that number would of course have to be 3. So our answer would be 3e to the power of 5x plus c. And if you differentiated this, you would get back to 15e to the power of 5x. So can we come up with a formula that kind of encapsulates this pattern that we've seen? Well, we just say that the antiderivative of a number, so b times e to the power of ax with respect to the variable x, is equal to b divided by a times e to the power of ax plus c. Might look a little bit scary, but it's not too bad. If we were asked to anti-differentiate 6e to the power of 12x with respect to the variable x, well then in this particular case, b would be 6 and a would be 12. So what do? Well, we keep our b there, our 6. We divide it by our exponent, our 12 here, multiplied by e to the power of our ax, or our 12x plus c. So we just end up with e to the power of 12x divided by 2 plus c. And the way that I like to kind of think of this is if you're just anti-differentiating, let's say it's 3e to the power of 5x with respect to the variable x, all we do is we bring this 5 or this exponent down underneath and it kind of becomes a division, okay? So we end up with 3 over 5 e to the power of 5x plus c. Now that trick's pretty handy and you'll start to get the hang of it with a few examples.